Alright, so now that we have the 3D printer moving in the correct direction, it is now time to calibrate the steps per unit of each axis and maximize the dimension of the 3D printer. When you upload this new Marlin firmware, the stock firmware has a dimension of 200 millimeters cubed. So the 3D printer that we have, the Robo 3D R1 Plus, has a larger dimension than that, but it's less than what's advertised out of the box. So I'm going to show you how to maximize the area of your print volume right now. Alright, so last time we left off, we were on line 853, just changing the true and false for the X, Y, and Z axis. So where we're going to go now is you can use Control F, and we're doing steps per unit. There it goes, default axis steps per unit. So I went to the Robo 3D website, and for the R1 Plus, it should be 80, 80, 800, and I want to say 723. And then we're going to go ahead and upload this to the 3D printer. And once this is done uploading, we're going to test the dimensions, or test the unit steps to see if they look accurate. Alright, so now I've uploaded the new x-axis and y-axis and z-axis steps per unit. So we're going to see if the 3D printer is currently moving correctly in those positions. So I'm going to go ahead and open Cura again. There we go. First thing we're going to run is, of course, the G28. Good stuff. So now we're going to raise it 10 millimeters. So G1Z10. Now that looks more like 10 millimeters than it did last time. Last time we raised it 10 millimeters, it basically went up like a full 25 millimeters. So now what we're going to do is do G1X200. And last time we did this, we weren't sure if it was actually moving 200 millimeters. And it is in fact moving 200 millimeters. So the volume on the Robo 3D is larger than 200 millimeters cubed. So we have about an extra 20 millimeters to go, but if you were to type in G1X210, the 3D printer won't move because it's limited to 200 millimeters cubed in the firmware. So now we're going to jump back to the firmware. We're going to close our Proctor Face UI window first. Jump back to the firmware, and we are going to go to, I think it's size of print bed. And that is on line 881. So the bed size, we're going to make 220 by 220. I've found that that is the best size on the Robo 3D. You can try to get like 223 out of it, but I like round numbers, so I'm going to keep it at 220. Alright, so we're going to upload this to the 3D printer. And we wait. And wait some more. Still compiling. Now uploading. And we are done. Alright, so we're going back to the Proctor Face UI window. Like before. G28 before we do anything. Alright, G1Z10. And then we're going to do G1X220. So now, instead of moving just 200 millimeters being stuck there, we actually move 220 millimeters, and that's the full length of the bed on the Robo 3D R1. Now I'm also going to check the Y direction as well, G1Y220. Now you can get more than 220 millimeters out of the Y-axis. I think you can get 245. But when you do that, you're off of the heated component of the heated bed. So I recommend staying at 220 for a Robo 3D R1 Plus. So now we can calibrate the Z-axis. The Z-axis is on a different line. So let's go ahead and see how far I can go right now. G1Z200. 200 should be what I'm allowed to do right now. So 200 millimeters is pretty tall. You can leave it there if you want to. I'm probably going to leave mine there because you start to get a little bit of tangling up at the top with all the gears and everything. But if you did want to change that, we're going to go ahead and jump back over to Marlin. I'm recording right now, Angela. What do you want? So right below the bed size on the Marlin firmware, you have max Z position. So I'm going to change that to maybe 220 as well and see how much I can get away with. I'm going to go ahead and upload that as well. Alright, so we're done uploading the extra 20 millimeters I added to the Z-axis. So we're going to go ahead and open the prompt interface UI once more. And it's going to take a while to get down to the bottom, so I'm just going to fade you over to right here. Alright, so now I'm going to go to the center of the bed. So G1, X110, Y110. I want to do this kind of fast, so I'm going to set the feed rate a little bit higher. Better, much better. Alright, and so G1, Z220. Now the Z-axis is limited to how fast it can run. We can increase the velocity of that soon, but that's in the next video. For right now, we're just trying to make sure that the dimensions of the 3D printer are correct and that the steps per unit are correct. Now I would test the steps per unit of the E-steps right now, but sadly, the extruder broke on this. So the next video you will see is me fixing this extruder. There it goes, way up in there. And I'm going to leave it at 220. It still can move freely up there, so G1, X0 and G1, X220. Might have stopped a little bit from grinding from something up there. But pretty much, most of the things that I print that are this tall pretty much come to a point in the middle, so they wouldn't be swinging back and forth like vigorously. But that's it for this video. So there you have it. We have now the dimensions set for the 3D printer in the X, Y, and Z axis, as well as the steps per unit to make sure that the dimensions we set are in the correct steps that the stepper driver can actually drive. If you like this video and want to see more like it, make sure you click that subscribe button. If you have any questions about this video or suggestions for future videos, make sure you leave a comment down below. In the next video, I'll be repairing this one because during my testing here when I was extruding this cube here, the hot end fell off. I have some video clip of that I'll show you in the next video. And then, I'll see you next time.